Can you guys hear me okay? Sweet. Good.
Coming through loud and clear.
Get going in a second here. All right, sweet. I think I'll go ahead and get started. Are you all good on recording, Aaron? Sweet, sounds good. Yes, this is just going to be a quick introduction to computer vision, assuming no prior knowledge. So the main reason I wanted to do this is I think this is a topic that a lot of people hear about. It's obviously kind of cutting edge, scary, computers taking over the world, robots going to shoot and kill you, kind of cutting edge tech. But people get scared off from it, I think, more than they should, even though it is really complicated what's going on under the hood. You don't really need to know what's happening under the hood to tinker with it, use it, have a lot of fun with it, even make money with it. I had an internship where I used quite a bit of this stuff, and granted, admittedly, my conceptual understanding of how the backend is implemented, not that great, but I'm just wanting to encourage more people to experiment, considering it's all open source. There's a lot of resources out there, and you don't even really need to write very much code to start tinkering with this stuff. There's all a bunch of code samples you can use. So again, not going to go into how this stuff works. I am going to try to give intuitive understanding, just that you guys can kind of have a metaphorical sense of what's going on. If anybody wants to dive deep into what's happening on the back end, I can try to answer questions at the end. So to start off, just give a little bit of a bigger definition for what computer vision actually is. And it's really just using a computer to see things. I know that's really general and vague, but it really is a very general category of computer science. There's a lot of different things you might use it for. They typically divide it into these four categories I list as classification. Like I could give you an image and I say, what is this? Is it a cat? And you can obviously say, yes, this is a cat. Or localization, like I know there's a cat, where is the cat? And you're able to put a bounding box around it and tell me the cat's right there. Or object detection is kind of what items do you see? And then you'll go and say, hey, I see a cat over there, duck down there, dog up there. And then segmentation is kind of where are the edges of those items, where it's same as detection, just cropping down all the way to the actual bounding, like pixel by pixel, of whether or not it is or is not the item. I'm going to focus mostly on object detection, but all these tools can generally do all of these tasks. But just to back up a little bit, starting with really general object detection, if I just use you, your brain, and your eyes, and I ask you, what objects can you detect? You'll probably say you see 3 bananas, an apple, 2 oranges, a bowl, and it's, I guess the next question then is, how exactly did your brain do that? And then the harder question is, and how would you teach a computer to do that? So just on a general level, there is that bowl of fruit is getting sensed by your eye. It's looking at it. Something happens in your brain to interpret whatever you sense, whatever you saw, and it's spitting out some meaning of you're seeing a bowl and some oranges and bananas. Similarly, we're just trying to grab input with our sensing device, in this case a camera or webcam, use the interpreting device of our computer and generate some kind of output. And so we're really trying to mirror the human brain here. And a lot of this kind of machine learning field is using neural networks, and that's really designed after what's actually happening inside of your brain, but I won't go too deep into that. So if you start to think of like, well, how do you do this with a computer? If I asked you to go and program a thing to detect bananas, whatever it might be, you might think, well, I'll be looking at pixel color values and seeing where a yellow object is. And it's a really, really hard task. It's not super straightforward. And so really how this actually works is black magic and lots of math. I'm not gonna touch that. Well, I can dive in a little bit, but it's not really worth going too deep into how they're modeling this. But instead, I'll just give you a really big picture on how ML achieves these tasks. So traditional programming, if you're writing in Python, maybe you're just adding two numbers, something super simple, is you're giving rules, the addition sign, and data, maybe 3 and 5, and that spits out some answer of 8 in this case. So you're providing the rules and you're providing the data, and the programming language goes to an answer. With machine learning, it's a little bit different because we don't really know the rules. We don't know how to identify a banana. We don't want to write really explicit color detecting code to identify a banana. That would be super difficult. Instead, we just give it answers. That is the label of what the thing is and a bunch of data of images of bananas or whatever you're trying to detect. And machine learning just figures out the rules. So this only works if you really give it a lot of input data. And you can kind of come back to the metaphor of if I ask you what fruit is this, and you can tell me it's an apple. The only way that you know that that's an apple is because you've gone to the supermarket and you've seen a whole bin of apples with the label apple right there in front of it. And you've seen an apple on a tree and had somebody say the word apple, and you've throughout your life constantly gotten visual input of looking at an apple next to some label, some data, and an answer for that data. So you're always getting that data of seeing the apple along with the answer or the label of what that is. And you don't know how your brain actually identifies that apple, but you don't need to. It's developed some set of rules for looking at that thing and knowing what it is. And this is really what computer vision does. It's just building those rules for you. But kind of, yeah, back to this, your brain knows what a banana is because you've seen a ton of bananas that were labeled as a banana. This is where it'll get a little bit more interesting as I'll actually start showing you what this looks like for a computer. So the basic gist is that we need to teach a computer what a certain item is. So let's say we were trying to teach a computer what a thumbs down looks like versus a thumbs up. So I need to find some way to give a computer a picture and say, this is a thumbs down, or give it a different picture and say, this is a thumbs up. So the raw format that this ends up being is a .xml file. Don't worry too much about the details here. Basically saying, hey, this image contains a thumbs down at these X and Y coordinates. This is just a little box that wraps that thumbs down. And if I give it this sample and I trained a neural network, it would find some rules where if it sees the pixels in this box, it'll know that that is a thumbs down. Now, if that really is only going to work for this exact lighting in my hand and kind of this exact orientation, because what if it's my hand facing the other direction like that, or something in somebody else's hand, or different lighting or different background. So generally when you're training this, you need to show it a whole bunch of different inputs and different contexts, different lighting, different people, different, you can even process the image to get different data, all sorts of clever stuff there. Won't get too deep into, lots of internet research you can do on how to get good training data, but you need a lot of data. If you had only ever seen one little green banana on a tree, and then somebody showed you a cartoon illustration of a yellow banana, you might not know what it is. You might not be able to assign a label to it, but you've seen all of these different things that are all still the same label, and you're able to then identify a new one, even if you haven't seen that exact one before. And so you might be thinking, well, I don't want to type out XML files and find X and Y coordinates, and you never will have to. A lot of the times you can get pre-labeled data sets online that just give you both files, or you can use a tool like Label.img is a really simple one. This is just an application you download where you can see I've drawn a box and I've labeled that box as a thumbs down. And then I go to the next image and I label that as a thumbs down. And I go to the next image. Oh, this one doesn't have a label. And I want to draw a box and I want to call it a thumbs down. And I say, okay. And I save that file and it creates that XML file for me. So this is the really glamorous side of being a computer vision engineer, is you spend hours upon hours labeling images with little boxes until your wrist hurts. This is the part that isn't as glamorous, but eventually you end up with a bunch of these different images. Here's friend study hall of thumbs up, thumbs down. I'm deliberately moving my thumb around, trying to get different types of input, but you're just trying to teach a computer what that item is and what it looks like. And there's, again, these tools, I'm kind of running through it very, very quickly, but none of these are very hard to use, and none of these really require that much programming. These are applications that people on YouTube will walk you through step by step, and it's not super hard to use. Just to then transition a little bit into how you would go about tinkering with this stuff on your own. I'll show you a couple of the resources that are out there. So there's a few different projects and tools you could use to do this, but most people use TensorFlow. It's kind of the most common one. It's a really common machine learning library, and they have what they call the Object Detection API. This is something you can just git clone. It is a public repository. This code is available to anybody. You run a little bit of setup. You can just copy and paste this into your terminal and then test that installation. And that's it. That is your entire setup. You now have very, very intelligent machine learning, computer vision software on your computer at home. And as far as actually using it, they give you a whole bunch of resources in that repository that you clone. There's all sorts of stuff going on in here. They give you a bunch of these collab tutorials that walk you through kind of the very basics of using all of this stuff. So for example, the simplest intro one, it does all your imports for you. It helps you import packages. I didn't write a single line of this code. This is all just stuff that's given to you by TensorFlow. If you want to dive in, if you're comfortable in Python, you can go and actually read through this stuff. It's all just a dictionary. A lot of this isn't super complex. A lot of defining functions and fetching files. It's not super hard to read through. It's pretty interesting, but you don't really need to understand it. It's just to start tinkering with it. Here you can see this is actually loading a pre-trained model is what this file is doing. So it's not using your own images. You're not defining your own labels. It's going out and grabbing one that somebody else defined for you. And you can see everything that they've labeled for you. So they've trained it on a bunch of what they call person. They trained it on bicycle, car, motorcycle, airplane, traffic light, bird. You can get a tie or a suitcase or a snowboard or a baseball bat, any of these things. It will know how to identify, even a toothbrush. And you can point to any image path that you want. It will load that image for you and run inference. This is just a fruit bowl I found on the internet. It's saying, hey, I'm 54% sure that's a banana. I'm 50% sure that one's a banana. 66% sure that one's a banana. And here's a bowl, and there's an orange and an apple, and another orange back there that's not quite as confident in. I guess it's not super confident in the oranges. Or even on a bigger image, it's looking at the kite or the people. And again, this is computer vision inference running on my machine after about 5 minutes of setup. This is not a hard thing to do, not a hard thing to get going on your own machine. And I didn't type a single line of code. Kind of the more interesting demo of this is you can actually run webcam inference, where rather than grabbing it from my image dir or some path, I can actually just tell it to grab from my camera. So you can see there's me. I am in fact a person. I can in real time, I'll hold up a mug. Sometimes the cup doesn't grab it, it's lighting as well. Oh, I'll detect my mug with the flat lighting. There we go. It pinged in there for a second thinking that was a cup. Let me grab something a little bit easier. It knows laptop really, really well. It's able to, even at different angles, be able to identify that that is indeed a laptop and all these different things. So it's real time running on my computer, grabbing from my webcam, running its black magic, running its crazy vector math, some stuff you don't need to know about or care about to have fun with this stuff, and give me an inference live and drawing a box around it. And getting up and going with this is not that hard. Even if you're listening to me say, git clone and run this in terminal, all that, and that sounds scary. I have linked in this, a link that I'll post. This course is really, really awesome. He says 5 hours. The good news is that everything important is in the first 2.5 hours. The bad news is the first 2.5 hours will still probably take you 5 hours. But this is from scratch. He walks you through step by step, every install, every bit of moving files around, every bit of labeling data. everything you need to do to label a fully custom data set to do whatever you want. And you can follow along. I think his is the thumbs up, thumbs down, thank you, as like a basic sign language detector. But you can swap those labels out for anything you want. And all of the code is right there for you. So if you wanted to follow this tutorial, but change the labels out, you could make a mask detector, for example, where you show it a bunch of images of a mask worn correctly, and one where the mask is either worn incorrectly or absent. And you can train a model that detects if a mask is worn correctly. And there's all these different problems that you can kind of, if you have an idea, you don't really need to be an expert in computer vision code to use someone else's code and still train that custom model. So I actually used this exact video on the clock my first week at a job when I had a part of a project required a computer vision model. I used a lot of his code. It's open source, and I think it's chunks of his code are probably still in production pipelines for my past internship, just because it's open source. And there's no need to reinvent the wheel. There's no need to recreate it. So I think just recognizing that there are a ton of these resources out there. Show you his repository here. This is the one that he walks through in the video. If you want to just dive in, experiment on your own, it's right here. But it's just a notebook that gives you step-by-step instructions on how to do this stuff. And again, it's black magic under the hood, but using it at a high level, it's just Python. You're just defining a list of labels, thumbs up, thumbs down, thank you. You're defining a path to a file folder. You're doing a for loop. Like, none of this is crazy code. The high level interface for this is really, really simple in a lot of ways, especially if you can just use other people's code to simplify things. So I would just recommend exploring this a little bit, reading the TensorFlow documentation. But if this sounds really, really scary to you, jump on a tutorial, put in the time, and you can kind of tick away at it over a couple of weeks and start to get the stuff running on your local machine. So I'll put all these links on Discord, just that if anybody is interested, they can dive in and kind of explore that a little bit. And yeah, if you ever hit problems with this, you can always ping me. I've dealt with a lot of weird bugs in this stuff. I guess the only thing I would say is this is still under development. It's what they call research, which basically just means they're changing it a little more often. So sometimes you'll find a tutorial that is a couple months outdated or a year outdated, and the API has changed a little bit since then. So you do have to be a little bit careful that you're not using old information on newer versions. But I think all that stuff is really good practice. I mean, getting tools to work with weird dependencies off of random internet information is a huge part of being a programmer in a professional environment. And even if you're just looking for a way to practice dealing with strangers' GitHub pipelines, this is a really good one to just explore and tinker and build that skill set. But that is really, really all that I had. I don't have too much to dive into on the actual TensorFlow front. But does anybody have questions, or if anybody wants to dive in a little bit deeper, I could try to explain some of what's going on behind the door. But anything? Crickets?
I was just, oh, sorry, go ahead.
Oh, no, you can go.
I was just going to say thank you for leading this bite session. That was very informative if someone who doesn't know anything about this. I was just going to ask what your internship was like, what their application was, and just wondering what your experience in the real world with this stuff, with what they're doing is.
Yeah, so I took 493 through, or 434 rather, through Patrick last year. Awesome course if you haven't taken it. I really recommend it. It has changed the trajectory of my life, I would say, a lot of ways. So I put TensorFlow as a random skill in a resume, or I guess scikit-learn. And I was applying to Intel at the time for a graphics position so the tool is GPA. They basically build a suite of tools for chip designers or video game designers to see where their graphics application is performing well, where it's not performing well, kind of what is bogging down your hardware. And so they saw that and they're like, oh, we have an AI project that we could bring you on for as an internship. Like, they thought I could tackle it. And so they did a couple interviews and thought I was qualified. And by AI, they meant computer vision, which I had never dealt with before. So I had kind of this panic moment, like, oh shit, I need to teach myself this stuff. So it was like a couple weeks before, like learning this exact same tutorial that I showed was what prepared me for that job. And the project that they had was essentially they have an automated test suite that runs certain graphics workloads. So whenever they have a new update to their application, they need to make sure it didn't break. A lot of different Unity and Unreal, all these game engines, will do really clever things to squeeze out performance. And sometimes that clever thing kind of circumvents their software and messes it up. So they just need to make sure that their new version of the software still works on all these demos. But the problem is they also want to test real world video games. Those are the workloads that matter most. And so they would release a new update and suddenly Cyberpunk wouldn't work anymore on their tool, or Tomb Raider wouldn't work anymore on their tool. And so they had engineers making $200,000 to $300,000 a year, even more, spending 4-6 hours every couple of weeks manually playing a list of about 20 video games. They had this super hideous spreadsheet of a list of video games and then a list of features in their application. And it was like, most of them were green, but every once in a while one would flick to red as somebody like found a bug or a customer reported a bug. And they were spending all this time on manual validation. So my job was to build essentially a system that captures the screen, runs a detection model and say, hey, where are the buttons on this screen? What elements on here look like a clickable button? It was a pretty simple detection model, and like in the end, it was just identifying one thing: identify buttons. And if it gets a false positive, that's fine. I just want anything that might be a button. And then for each of those little buttons, it would crop down to it, run an OCR, optical character recognition, and identify what text is within that button. So there's like the little leave button in the bottom of the Zoom window. It would detect that, crop down to it, and identify the text of leave. And so then you have this list of button objects that all have a location on the screen, XY coordinates, and a label. And so then I, as a script writer trying to write an automated thing, I can say, all right, load this video game. I want you to wait until you see the text menu, and I want you to click play game, click continue mission, click start, and click OK. And it'll search for those buttons until it finds it, and then automate a mouse click, and then search for until it finds it, automate a mouse click. This ended up being a super high-level Python scripting that you could do, where you could write a 10-line, 15-line script that would do lots of intelligent stuff behind the scenes and automate video games, really just to walk through the menu. Maybe you run forward for 15 seconds once you actually load a video game, just to make sure that you're actually rendering. Because a lot of times the menu screen won't actually fire up a graphics engine, so you have to get into the gameplay somehow. And that's a really hard thing to automate. And so yeah, I just built a kind of complete Python API that was exposed to their developers to script these video games. It ended up being, the detection model was a very small component of it, but it was mostly just this kind of Python automation library. But yeah, sorry for the long-winded answer. But
Thank you. That was a really great answer.
Super fun project though. And it was cool too, because in theory it could automate anything with a GUI. There's all sorts of malicious ideas. If you wanted to plot, you could automate anything on the internet you wanted. I think if you're wanting to do a DDoS attack or something like that, a lot of them get detected because it doesn't look like human input. Or you could use a system like this to fake with random wait times and random clicks and kind of simulate human interaction a lot more. So there's all sorts of weird use cases that come to mind, but they took the source code back and won't let me touch it. So, but yeah, any other questions?
Yeah, thanks for doing the presentation. I was wondering if you had any like kind of personal interests or fun projects that you're interested with visual computing.
I haven't done really much with computer vision for my own. I'm doing a machine learning project with Patrick right now for forecasting river levels, to trying to like predict the volume at a gauge site. But I haven't done any external projects. I think I worked through a few examples when I was learning this stuff. Like even that detection course, they go through, I think, detecting on little LED lights whether or not one of the prongs is bent and defective. So you could have like a camera on an assembly line that would set off a little alarm when one goes past that has a bent part, something like that. So that was one project that I did as well. But I haven't done too much with it, to be honest, since that internship. But I would like to do more though.
Yeah, I'm sure it's a lot of time, and then yeah, schools are always busy. So
and really, labeling data is the biggest time-intensive part of this. This is why Facebook loves when you tag people. You are giving them training data for their facial recognition algorithms, like without a doubt. That is so valuable to them. their primary market is ads and increasingly data mining their users. And anything like, there's even a funny example I saw where, you know, the reCAPTCHA things where it says, click all the images with a bicycle. Sometimes they'll give you two. They'll give you one that is actually to verify you're not a robot. And the second one, they don't actually know where the bicycles are. There's not a right answer. You could click anywhere and it would still get it through it, but they're using you to train data for other reCAPTCHAs, because labeling reCAPTCHAs is really time consuming. So they're just using you to train their computer vision model for the heck of it while they have you for 5 extra seconds. And that 5 seconds is worth a lot of money to them. And so it's this huge space of labeled data is hard to come by and really time consuming to create. There's all, if you go into the space, be careful. A lot of internships will just make you a data labeling slave for the entire summer is kind of the thing I've heard horror stories of. But there's even entire companies set up where you can give them 50,000 image files and pay a fixed price, and they will go through and hand label every image and give back to you XML files alongside the JPEGs. And so there's entire companies that have sprung up, just like almost like click farms all over the world where labor is cheaper than in the US. So a lot of companies will even outsource that when interns aren't cheap enough, they outsource it even overseas, just that data labeling function. So it's, yeah, it's really, really interesting thing to watch, but.
Wow, that's crazy.
It's time consuming to do. And the more data you have, the better quality your model will be, almost without fail. Like, just no matter what, it gets better the more you can give it. Yeah, and application, this stuff is everywhere. It is insane how much is starting to get implemented into.
Yeah, what are you or how are you applying prediction? You were talking about predicting flow.
Yeah. So that project is, I guess, still ongoing. So it's a little bit up in the air on the exact model we're going to use, but general idea of it is for a river gauge. So this can be very off topic, but a given river gauge kind of will fluctuate quite a bit in level, but it's mostly affected by rain and snowpack and temperature throughout the catchment. So the idea is for every single tributary to that river, you want to grab as much weather data as you can, ideally 30, 40 years worth. Then you're feeding all of that in as your input, saying, hey, these 5 days of weather led to this river level on the 6th day as your kind of your input and your answer, your data and your answer. And then it's going to go and build some model that is able to go from the last 5 days of weather, or even the next forecasted 5 days of weather, and give you what's going to happen next on the level. So it's, yeah, gotten at least a proof of concept working that gives us useful forecasts. It's not perfect yet, but diving in deeper and trying to get more accuracy out of it, been fun. Patrick's a good one if you haven't had him for much yet.
Yeah, I have. I had him. I'm having him the first time this term for analysis of algorithms.
Of course, yeah,
it's definitely pretty cool.
434 is awesome. That it's super cutting edge stuff, and it's what he's passionate about, which definitely I think makes a difference when your professor actually is passionate and does research in the subject they're teaching. And I didn't know this until very recently, but Patrick actually runs a lab that's mostly Corvallis students. He runs the Sound Bender lab and is doing a whole bunch of really awesome sound processing machine learning research with about 15 to 20 Corvallis students most of the time. So just, yes, sir, recognizing that he's doing cool stuff and publishing papers occasionally still.
Yeah,
oh, that's cool.
I worked with Patrick on another ML project for a little while this year, and if you're ever interested, definitely just hit him up, ask him what he's doing, and or if you have an idea, like he always wants to spin up new projects.
He always has research running in some kind that
for sure, yeah.
Happy to throw you at. And it's a really cool way to get experience. I mean, I've loved doing that work. It's just kind of to specialize in on one problem for a whole term is really valuable. Getting off the computer vision train. Any other questions on computer vision side of things? I can point you in the direction of where you can learn about the matrix math going on under the hood if you really wanted to, but that's all a little bit gross. Erin's shaking her head. That one out. leave one of my Zoom meetings. But awesome. Yeah, thank you all for coming, and go tinker with it. I recommend it. It's not that hard. You'll deal with some dependency issues, and it's just expect to do a little bit of Googling, a little bit of Stack Overflow to get all the packages lined up and working correctly, but it's all nothing too crazy, and all the code is there for you. But I recommend it.
Thank you, Orion. That was really cool. I can already imagine like a bunch of ways we can incorporate it in like our apps. So very
Yeah.
cool.
Stand on the shoulders of giants and use what they've given you for free online.
Yeah, thank you.
Yeah, see ya.
Sweet. See you guys. Thank you all.
Thank
See
you.
ya.
Yep.